Hello everyone, now we're going to solve Cambridge IGCSE Physics, May June 2025, paper 2-2. Number 1. Which instrument is most suitable to determine the volume of a small irregularly shaped stone? Because it is an irregular object, we have to use the water displacement method, which involves using a measuring cylinder. C. 2. A steel ball is dropped from the top of a building. Air resistance can be ignored. Which statement describes the motion of the ball? A. The ball falls with constant acceleration. Well, this is true because there is only one force acting on it, which is the gravitational attraction from the earth, and it has a constant value. B. The ball falls with a constant speed. We know that there is acceleration, so speed will be increasing. So speed will be increasing. This is not true. D. The ball falls with increasing acceleration. Well, we just mentioned it is constant. So D is also wrong. 3. The diagram shows a velocity time graph for an object which is accelerating. What is the acceleration of the object? We have velocity time graph. So we find the gradient, we get the acceleration. So we get 2 points here, 0, 20 and 40, 120. So 100 divided by 40 is like 2.5 meters per second squared. So B. For diagram 1 shows a piece of flexible material that contains many pockets of air. Diagram 2 shows the same piece of flexible material after it has been compressed, so that its volume decreases. Diagram 1 before compression and 2 after compression. So what happens to the mass and to the weight of the flexible material when it is compressed? So volume decreases. Now we have something called volume and mass, and we can think about density already. So density is equal to mass over volume. So because this volume decreases, the density will increase when mass is constant. So mass will have no change, and so weight will also have no change because weight is just the effect on the mass. 5. A student determines the density of copper. She has a rectangular block of copper. Which other apparatus does she need? So we can look at the equation here, mass over volume. So we need to find mass, so balance, and it is a rectangular block. So we can use a ruler to measure the dimensions. So ruler is also needed. Stopwatch, there is no time here. Thermometer, there's no temperature here, so only these first two. So it's going to be C. Number 6. A 0.15 kilograms mass is suspended from a vertical spring. The mass is pulled downwards until the spring has extended by 12 centimeters from its stretched length. The spring constant of the spring is 30 newtons per meter. What is the magnitude of initial acceleration of the spring when it is released? So firstly, we need to think about how to get to acceleration. So we know equations about acceleration that involves mass, which is resultant force, is equal to ma. And we know the mass, we want the acceleration, and we can find the resultant force from the given information here. So firstly, we have something called F is equal to kx, and spring constant is 30 and extension is 0.12 meter. So you will get 3.6 newtons. So when we think about resultant force, we have to consider all the forces acting on the spring. So we have downward force, which is going to be its weight, and this force, So we need to consider the direction of this force. Even though we apply the force downwards, it actually is a restorative force, which means it will try to get back to its original displacement. So the actual original equation looks like this, because force is trying to oppose the displacement. If not, it will just be like, it will just keep stretching and becomes like this, and it doesn't make sense. It's trying to oppose the displacement. So this is the actual original equation that you need to consider, which means this will have a negative value. It will be adding upwards. The force will be adding upwards. So we know the weight. It is just this multiplied by 9.8. So net force, well, because we only need to consider the magnitude, it's fine whether you set direction upwards plus or downwards minus. And now we get, to make things more simpler, weight downwards will be positive direction, 9.8 into 0.15 minus 3.6 is equal to 0.15 into acceleration. So 9.8 into 0.15 subtracted by 3.6 divided by 0.15, that is you get minus 14.2, but only asks for magnitude, so it's fine. And it's approximately 14 meters per second squared. A. 7. A cricket ball of mass 0.15 kilograms is moving at a speed of 30 meters per second. The diagram shows a batsman holding a bat stationary as the ball hits the bat and bounces back at the same speed in the opposite direction. The ball is in contact with the bat for 1 to 10 power negative 3 seconds. The table shows the change in momentum of the ball and magnitude of the force applied to the ball. So which row is correct? So change in momentum is mass into V minus U, and mass is 0.15. And final velocity will be 30 minus, and because it is in opposite direction, right? One of the speeds will have to have an opposite sign, which means if we put positive here, we have to put negative here. And this will be equal to 0.15 into 60 will be equal to 9.0. It's either C or D. And force applied to the ball, F, is equal to rate of change of momentum, which means this change of momentum divided by the time taken. So it will be D. 8. A stone is thrown vertically upwards at a speed of 5.0 meters per second. All of the energy initially in the kinetic store of the stone is transferred to its gravitational potential store when the stone reaches its maximum height. Which equation gives the maximum height reached by the stone? So the original kinetic energy will be 1/2 into okay, it doesn't give the mass, but yeah, 1/2 mv. We don't really need the mass, but okay, 1/2 into mass into velocity squared will be equal to mgh, and g is 9 point. Okay, so I'll just substitute directly. G is 9.8, and this is the height that they want, and mass cancel out, so h will be equal to 2 into 9.8. This is 25. Okay, so they just leave it as 5.0 squared. So it is equivalent to C. 9. 3 energy resources are listed. geothermal, wind, and nuclear fuel. Which resources get their energy from the sun? Geothermal comes from the core of the earth, in the middle, like inside of the earth. So no. Wind, it does come from the sun because of the energy, right? Because of the heat of the sun, there is difference in temperature of the air itself, and then it causes convection currents, which causes wind. And nuclear fuel comes from the nucleus of the atoms. It has nothing to do with the sun, so 2 only. D. 10a. An example of a substance has a shape that is determined by its container. What are the possible states of this sample? So, determined by its container. Liquid for sure will be in it, and also gas, because just like spreads to fill the container. But solid has a rigid shape, so no. B. 11. A stationary smoke particle is hit by a fast-moving nitrogen molecule. Which rule describes the motion of the smoke particle and the nitrogen molecule after the collision? So this is describing Brownian motion, and so the fast-moving nitrogen molecule is a smaller one. It is faster. It's moving randomly, zigzag motion, and that causes the small particle to move as well, and it doesn't stop, like they will rebound because the small particle is heavier, right? A. 12. A bubble of gas rises from the bottom of a lake to the top. The table shows readings of the gas pressure inside the bubble and the volume of the bubble. The temperature of the water in the lake is constant. The values in 3 rows of the table are correct and 1 row is not correct. Which row is not correct? So we have pressure and volume. We know this equation where PV is equal to constant. So we can multiply all these values and find the constant, and if it has a different constant, then it will be the answer. So 360 into 2.4 is 864. Okay, I'll just write it down just in case. 270 into 3.2 is also 864. 160 into 4.6 is 736. So this would be the incorrect answer. 120 into 7.2 is also 864. 13. The diagram shows a glass flask sealed with a small volume of mercury in a glass tube. 1. The flask is gently warmed. The mercury rises up the tube. What is the main cause of the movement of the mercury? So it moves, which means that the volume in here, the air inside will have a bigger volume. So it will because of the expansion of the air. 14. The diagram shows equipment used in an experiment to determine the specific heat capacity of a metal. In the experiment, a heater is switched on for T seconds, and the increase in temperature, delta theta, of a block of the metal is measured in degrees Celsius. Which equation gives the specific heat capacity of the metal? So it's just asking for the equation. So we need to know its original form. C is equal to E into M delta T. And now it's with power, and we know that energy is equal to power into time. So it's just PT divided by M delta T, which is B. 15. The diagram shows 4 rods. Each rod is made of a different material. Wax is used to attach a small metal balls at the rod ends P, Q, R, and S. Each rod is the same size. They are heated uniformly by a Bunsen burner at point X. As a rod warms up, the wax melts and the balls fall off. Why does the ball on the silver rod fall first? So falling first means getting heated faster, right? Which means the heat conduction process is faster in silver. So silver will be the best conductor of heat. 16. Three solid copper spheres X, Y, and Z are heated to the same temperature. Which rule gives the order for the rate of emission of radiation? So one surface area is larger, then the rate will also be larger, and for black surfaces it will also be faster. So X will be the highest, and second highest will be the one with the larger diameter, X, Z, and Y. So B. 17. Which wave will diffract the most when passing through a gap that is 0.85 meters wide? So when considering about diffraction, we need to think about wavelength. And now they don't give wavelength, but we can find it by using equation V is equal to F lambda. And the most diffraction will happen when the wavelength is the greatest, like much bigger than this. So here for number A, that is 300 divided by 280 is about 1.07, and 300 divided by 400 0.75. For C will be 1.25, and for D will be about 0.875. So clearly C has the largest wavelength, so we'll choose C. 18. Which arrow on the graph shows the amplitude of the wave? So amplitude is just from the rest position to the highest point, so B. 19. Which rule describes a seismic S wave? So S wave is transverse. This is something that you have to remember, and because it is transverse, it will be perpendicular to the direction of the travel of the wavefront. D. 20. The image of an object is formed by a plane mirror. Which rule gives the correct properties of the image? So plane mirror will give you a virtual image, and it will have the same distance. D. 21. A ray of light traveling in air is incident on air glass boundary. The angles between incident ray and refracted ray and the boundary are shown. Which equation is used to calculate the refractive index of N of the glass? So it is coming from the air. So angle of incidence divided by angle of refraction, and they given the one with the boundary, not with the normal. So we have to subtract from 90 degrees. So it'll be sine 40 divided by sine 26. A. 22. A small object O is placed near a convergent lens as shown. The lens forms an image I. Which statement is correct? So this is a convergent lens, like magnifying glass. So it is formed from the tracing lines, not from the actual convergent, which means it is not real, it is virtual. So I is diminished. No, we use it for magnifying glass, so this is wrong. I is inverted. No, it is upright, and like I said, it's a virtual image. So object O, it is closer to the lens, then it's principal focus. Only then you get this magnifying effect. So D. 23. What is the approximate speed of light in air? That is 2.0 into 10.8 meters per second. So C. 24. A ship sends an ultrasound pulse to the seabed to measure the depth of the sea. The speed of ultrasound waves in seawater is 1500 meters per second. The pulse takes 4.6 seconds to travel to the seabed and back to the ship. What is the depth of the sea? So distance is equal to speed into time, and speed is 1500, and time is 4.6 divided by 2 because it is like for both journeys. So if we put that in calculator, we get 3,450 meters, which is approximately 3,500 meters. 25. A dolphin has a range of audible frequencies of 150 Hz to 150,000 Hz. Which range of frequencies can be heard by both humans and with good hearing and by dolphins? So for humans it is 20 to 20k. So we can find something between them. 20 Hz to this can be heard by dolphins. 20 Hz to 20,000 is also too big for humans, and 150 to 20,000, this would be the correct answer. 26. A positively charged balloon is placed against a wall. The charge makes the balloon stick to the wall. Which statement explains this? So stick to the wall, which means it will be attracted. So we can choose like from A or B, and positive charges attract the electrons because they are unlike charges. 27. A student is trying to determine the resistance of a lamp. He sets up the incorrect circuit shown. Which change would allow him to take the measurements needed to calculate the resistance of the lamp? So firstly, voltmeter has to be connected in parallel, not series. Ammeter is in correct position, so we have to disconnect the voltmeter and connect it in the parallel with the lamp, D. 28. A metallic wire X has a resistance. What is the difference in resistance for a wire of the same material as X that is shorter than X but same diameter, the same length as X but a smaller diameter? So we have this equation: resistance equal to rho L by area. Area is the cross-sectional area. So rho is the constant because it is same material, and this is length. So resistance of shorter wire, if length decreases, resistance will be decreased as well. And smaller diameter means smaller area, which will make the resistance increase. So it will be C. 29. The diagram shows a circuit for a potential divider. Which equation is used to calculate V1? So we have this V1 divided by R1 is equal to V2 divided by R2. So V1 will be V2 into R1 divided by R2. So B. 30. Which electrical device is used to convert AC to DC? Oh, this is diode. Diode looks something like this. If the current is in the if the current is in the wrong direction, then it won't allow the current to flow. 31. A cell is connected to a parallel combination of 2.0 ohms resistor and a 4.0 ohm resistor. The current in the 4.0 ohm resistor is 1.0 ampere. What is the current in the cell? So in parallel connections, current is going to be different and depends on the resistance. So if the resistance is higher, then the current will be lower by the same ratio, right? So this is like twice as higher, so current will be twice as lower, which means this will get like 2.0 ampere. And if we add these currents from parallel branches, we get 3.0, which is D. 32. When there is an electric current in long straight wire, a magnetic field is created around the wire. Which diagram shows a correct pattern and the direction of magnetic field lines around the long straight wire carrying current into the page? So first we can cancel out something, right? We can cancel out C and D because the field lines, it will be the closest to the wire because the field is the strongest there, and then as the distance increases it will become like weaker. And we use the right hand thumb rule, and the thumb will be right hand grip rule. So the thumb will be into the page, and then you can see your fingers like curling in anti-clockwise direction. So it will be B. 33. The primary voltage supplied to a transformer is 3.0 volts. The secondary voltage is 5.0 volts and the secondary current is 2.0 ampere. The transformer is 100% efficient. What is the primary current in the transformer? Because it says 100% efficient, you know that the power in primary circuit is equal to power in secondary circuit. So current that we want into 3 will be equal to 5 into 2, which is going to be like 3.33 and so on. So C. 34. When a thin gold foil is bombarded with alpha particles, some alpha particles are deflected through large angles. Which statement explains the deflection? So because they deflect in large angles, it is like repelled by something in the middle. So we go through the options. Most of the atom consists of empty space. This is a true, correct statement, but doesn't explain the deflection, because if it's just empty space, then why do they get deflected, right? So B, all of the positive charge and most of the mass of the gold are concentrated in a small volume. So we know the alpha particles are positive. So this also has positive, and this explains the repulsion. And also says some and not most. So if it is in a small volume in the center, then this can explain the deflection. C, positive charge in the gold atom is spread evenly throughout the atom. Well, this is not true, and also this doesn't explain about the deflection for some alpha particles. D, all of the negative charge is concentrated at its center. Negative charge will only attract the positive charges, so this doesn't explain deflection as well, and this is also not true. 35. A detector near a radioactive source shows a reading of 2000 counts per minute. How is the corrected count determined? So you need to know that this contains background radiation. So if we want the correct one, then we need to exclude the background radiation. How to exclude that? Well, we can remove the source, put the source away and just measure without the source. We get the background radiation and we subtract that from here. So A, by moving the detector close to the source. Well, this could work in some way, but we'll find a more accurate way to do this. B, by placing an absorber between the detector and the source. Well, if that happens, then you won't even get anything, right? It's also wrong. C, by repeating and averaging the measurements, but the background radiation is still there. D, by taking away the background radiation count rate. Or this is what I described earlier. So D. 36. Which statement about alpha, beta, and gamma radiation is not correct? A. Alpha particles are deflected most in electric field. They're not deflected the most. Beta particles are deflected the most because they are lighter, so it's like easier for them to be deflected. So A is the correct answer. B. Beta particles are deflected most in a magnetic field. This is true. Gamma radiation is not deflected, no, because it doesn't have mass. D. Gamma radiation is least ionizing. Gamma radiation is not at all ionizing, so that doesn't really count. 37. A sample of radioactive material has a half-life of 20 minutes. Which statement is correct? After 30 minutes, less than half of the material has decayed. This is wrong because after 20 minutes, exactly like half of it will have decayed. So after 30 minutes, more than half. B. After 40 minutes, all of the radioactive material has decayed. This is also not true. It's only after like 2 half-lives, so it will be like 1/4. 1/4 will remain. C. After 60 minutes, 1/8 of the radioactive material remains. Yes. So there are like after 60 minutes, right? 3 half-lives will have passed. So 1.2. 1/2 power 3 is 1.8, and this much will remain. After 120 minutes, 6 of the radioactive material remains. After 120 minutes is like 6 half-lives, so 1/2 6, that is like 1/64, so that is not true. C. 38. Which statement is correct? A. The Earth orbits the Sun once in approximately 24 hours. Well, it completes the orbit once in like 1 year with 365 days. So, wrong. B. The Earth orbits the Earth orbits the Moon once in approximately 1 week. This is also not true. C. The Moon orbits the Earth once in approximately 1 month. D. The Sun doesn't orbit the Earth, so this is also wrong. C. 39. Stars are powered by nuclear reactions that release energy. Which statement describes the nuclear reaction in stable stars? So nuclear reaction happens in the stars is nuclear fusion, which converts the smaller lighter elements into bigger ones, and converts hydrogen into helium. D. 40. A galaxy is moving away from the Earth at a velocity of 3,000 kilometers per second. What is the distance between the Earth and the galaxy? So we have this equation: v is equal to h0 d, and velocity is 3.0 into. We'll convert that to meters directly. 3.0 into 10 power 6, and h0 is 2.2 into 10 power minus 18 d. So if we put that in calculator, we get C. If you can't remember the value of h0, you can actually calculate it. So we know that 1 by h0 is equal to the age of the universe. So if we know the age of the universe, which is approximately 13.8 billion years, we can get this in seconds. So 1 by 13.8 into 10 power 9, this is in years, and 365, 24, and 3,600. So if you don't want to remember this value, you can calculate this on the spot. You get approximately 2.3 something, but the values here are very different, so you can approximate that. So this is the end of the paper, and go back with your studies.